Hey guys. All right, so this is our final chapter of the year, which is linear equations, x, y, or input-output tables, and stuff like that. So let's get started with nice and basic scatter plots. Now, when you plot a scatter plot, you're basically using your x, y table and filling out the dots. And if the dots make sense, they will make kind of like a line. And if you read this scatter plot from left to right, you should have a line that goes up to make a positive change. All right. If you read it from left to right and your dots start high and they go low, then that would make a negative relationship. And then this guy doesn't really have a nice line. You can't really draw a line, and there's a lot of outliers. So this one would have no relationship. And to test that, you can just take a highlighter and draw a line through your dots. All right, so when we say x, y, we also can say input, output. They mean the same thing. So your input is your x, your output is your y. Now, when we are using linear equations, we have to make sure that our xy table is a function. So with that, that means that you don't have any repeats in your input or in your output. So in this, I have a 1, 2, 3, 4, 5, 6. So there are no repeats in my x table. For my y, I have 2, 4, 6, 8, 10, 12. There are no repeats in that one. Because there are no repeats, that is a function. Now you can ignore the fact that the y and the x have the same number. They both share 2, they both share 4, they both share 6. But that doesn't really matter because this one's your input, this one's your output. So they're different lines, they're different columns. But this one is not a function because there are repeats in specifically your input and in specifically your output. So x, I have 1, 2, 1. All right, so I have my ones repeated, and I cannot have that to have a function. 3, 4, 5, those ones are good. This side, I have 2, 4, 5, 8, 4, 10. All right, I have repeats of the 4s. So that means that this one is not a function at all. All right, so when we are finding our linear equations and writing them with the table, we need to use this equation. So y equals mx plus b. And this might look familiar to you. This is a pretty common equation most people know. And basically, you want to find your m first. Once you find m, you can solve for b because you should know what your x and y are. So let's get started on that. So here's my xy table. First thing I need to do is find my m. And my m is basically my y divided by or over my x. My output over my input. So not just my output over my input though. I'm talking about the change of my output or the change of my input. So let's look at this. I have 5 to 6. So I know from there it's plus 1. From 6 to 7, that's also plus 1. 7 to 8 is plus 1, and that's not a 4, that's a 1. All right, now let's check out my x. So I have negative 1 to 0. That is also plus 1. 0 to 1, 1 to 2, it's all plus 1. So I'm going to replace my change of y and change of x into what the change is. So y is a 1 and my x is a 1. So 1 divided by 1, or 1 over 1, equals simply 1. That one's nice and easy. They're not all this easy. Oop. All right. So in my equation, my y equals mx plus b, I can replace this as y equals 1x plus b. And when you have your functions, your table, then you're able to solve for b using just one of your x and y's. We always use the easiest one, like the 0, to solve first. So let's try that out. All right, so we want to fill in our y first, and my y would be 6. So y equals, so I'm going to put my equals, mx, so m we found out was 1, x we found is 0. I'm going to put that in parentheses. And then plus b. We don't know b, so that's what we're trying to find. All right, so nice and easy. What is 1 times 0? That is 0. So 6 equals 0 plus b. Now that's a positive 0. I mean, 0 is 0, so it doesn't really matter. So I'm going to subtract 0 to both sides or cancel itself out. And so now I have 6 equals b. So now I know what all of my factors are. I know my y's, I know my x's, I know my b, and I know my m. So now I'm going to rewrite this problem, my y equals mx plus b, in the linear form. So because the y and the x change, I'm going to keep them as just y and x. So I have y equals mx, so m is 1, 1x plus b we found out was 6. Okay, and because that 1x really doesn't need to be like that, you could also write it as y equals x plus 6. Now again, this table was nice and easy, and if you try it out, y equals x plus 6, x plus 6. 0 plus 6 is 6. 1 plus 6 is 7. Works perfectly. Okay, so this one was nice and easy, but let's do another one where m is not going to equal 1. All right, so we have our y change is 1 to 4, which would be adding 3. Then check, make sure that the whole thing works out. So 4 plus 7, or 4 to 7 is plus 3. 7 to 13 is plus 3. 13 plus 6 to 16 is plus 3. All right, your x, 0 to 1 is plus 1, plus 1, plus 1, plus 1. So this one would just be plus 1. All right, I'm going to put my y change over my x change. So I have 3 over 1. Well, 3 divided by 1, that's nice and easy. That just equals 3. So we already know that m equals 3. So let's try the easiest one, 0 and 1. So if I replaced my equation, I'll write that up again. Remember, y equals mx plus b. So if I rewrote my equation, replacing it with the easiest terms, so y equals 1, my x equals 0, and then I fill in what I know, so I know that 3 is my m. We're going to put parentheses around the m this time, plus b. All right, 3 times 0 is simply 0. So this whole thing cancels it out. So now we know 1 equals b. And finally, the last step would be rewriting that whole problem out with y and x as just simply y and x. So y equals, my first step is finding m. So 3 is m. X is going to stay the same. And then plus b, which we just found out is 1. So let's try that out. Y equals 3 times x plus 1. So 3 times 0 is 0, plus 1 is 1. 3 times 1 is 3, plus 1 is 4. 2 times 3 would be 6, plus 1 is 7. So our equation does work out in this problem. And that's basically y equals mx plus b and finding how to write a linear equation with a table. So let me know if you guys have any questions, and we'll go from there.